Hey everyone, I'm sorry I'm not able to be in class today, but I am doing the video for you today because I care about you and you matter. All right, so we're looking at lesson 1-6 right now, so make sure that you have your books open to this page, or in my morning class, of course, you just need to have this packet in front of you and go through each of these problems as I discuss them. Here we have one band's streaming video concert to benefit a global charity costs $1 to view. The first day the concert got 2,187 views. I'll circle that here. Now I got to get a pen chosen here to do that, don't I? Here we go. 2,187 views. The second day it got 3 times as many views. On the third day, 3 times as many views as on the second. And if this trend continues, how much money will the band raise on day 7? So we have 2,187 views on the first day. But then each successive day after that, we're going to multiply by 3. So multiply by 3 for day 2, multiply by 3 for day 3, multiply by 3 for day 4, by 3 for day 5, by 3 for day 6, by 3 for day 7. That's a lot of 3's being multiplied together. So what I want you to see here is I can take all of these 3's being multiplied together and write them with a single exponent. So we could say 2,187, that was the number of views on the first day, times 3 to what power do we have here? 1, 2, 3, 4, 5, 6 to the 6th power. This expression right here represents a good estimate for the number of views on day 7, if that trend were to continue of it tripling every day. All right, so here I have an example of the weight of a newborn male caribou. It's shown on the right. It says here it's 2 to the 3rd power pounds at birth. Some of you that are pretty good with your math, 2 to the 3rd power, 2 times 2 times 2 is 8 pounds at birth. They're little when they're born. So anyway, the weight of a newborn male caribou is shown on the right, 2 to the 3rd. On average, an adult male caribou weighs up to 2 to the 6th times more than a newborn. How can you determine the average weight of an adult male caribou? Well, what you could do is take its birth weight, 2 to the 3rd, and then multiply that by 2 to the 6th. Okay? And that would give you the average weight of an adult male caribou. So I'm going to show you here, this is what it shows in your book. One way you can do this, you can see here 2 to the 3rd really means 2 times 2 times 2. 2 to the 6th really means you have 6 2's being multiplied together. If you join these all together, you can see we have 9 2's all being multiplied together. So wouldn't it be nicer just to write 2 to the 9th as an expression of the weight of an adult male caribou? Yeah, I think it would be easier, nicer just to write it like that. But there is another way we can do this same type of problem. If you have 2 to the 3rd times 2 to the 6th, a nice shortcut you can use, since you have 3 2's here and you have 6 2's here, then we have a total of 9 2's that are being multiplied together. Okay? So the shortcut for finding 2 to the 9th here is just take your exponents, the 3 and the 6. Sorry, my arrows are sloppy. And just add them together. 3 plus 6 is 9. This is called the product of powers property. And so 2 to the 3rd times 2 to the 6th is 2 to the 9th. And what would that be, about 512? Is that right? 2, 4, 8, 16, 32, 64, 96. Well, I just screwed up. 128, 256, 512. Yeah, 512 pounds for an adult male caribou. But we can just express it as 2 to the 9th. That's the point of this lesson here, is seeing we can just add these exponents together. So 2 to the 3rd times 2 to the 6th is 2 to the power of 3 plus 6. The key to this is your bases have to be the same. And in both of these, we're working with 2's. We're working with a base of 2. All right, the local zoo welcomed a newborn African elephant that weighed 3 to the 4th kilograms. It is expected that at adulthood, the newborn elephant will weigh approximately 3 to the 4th times as much as its birth weight. What expression represents the expected adult weight of the newborn elephant? Well, if it's 3 to the 4th times as much as its birth weight, then you can take its birth weight, 3 to the 4th kilograms, and you can multiply that by 3 to the 4th kilograms. Now that will equal 3 to the power of 4 plus 4, or 3 to the 8th kilograms. Okay, so an adult elephant would weigh 3 to the 8th kilograms. And yes, you could solve and see what that is, but we're going to leave it just written, expressed with that exponent, 3 to the 8th kilograms. Okay, so why? Why does the product of powers property make mathematical sense? Well, because it's a shortcut. This means 3 times 3 times 3 times 3. And we're multiplying that by another one that means 3 times 3 times 3 times 3. So you can see we have 8 3's all being multiplied together, so why not just write it like this? Shortcut, add your exponents. Okay? Take good notes, it'll help you tremendously. All right, find the volume in cubic inches of a cube with edge length of 2 feet. All right, we have a cube with edge length of 2 feet. All right, so volume is 2 cubic feet then, 2 to the 3rd cubic feet. Because if you're finding the volume of a cube, you take length times width times height, which are all the same. So you have 2 times 2 times 2, right? That's where we get 2 to the 3rd power. 2 feet by 2 feet by 2 feet, because each edge length is 2 feet long. Okay? Now, keep in mind, we want to find this answer. Find the volume in cubic inches. Well, that makes this problem a little bit trickier, because instead of expressing this in feet, we need to express this in inches. All right? Now, 1 cubic foot is 12 to the 3rd cubic inches. Okay? Because each of these edges, the number of inches is 12 times the number of feet. So let me walk you through the steps here as they're shown in the book. We have 2 to the 3rd cubic feet times 12 to the 3rd cubic inches. Okay, this means 2 times 2 times 2. This means 12 times 12 times 12. So that's what's being multiplied together. Now I can do a little regrouping, and I can just start pairing up, like here's a 2 times 12. Here's a 2 times 12. Here's a 2 times 12. And I can group them together like this. And by doing that, I can actually say I have 2 times 12 to the 3rd power. And I can do the math here and see that would be 24 to the 3rd power cubic inches. Okay, now that's kind of a lot of work when really all we'd have to do is just realize, well, if this is a 2 by 2 by 2 foot cube, I can see I'd have to multiply each of those by 12 to get it in inches. And so it would be 24 by 24 by 24 inches, okay, which is 24 to the 3rd cubic inches. All right, so we can see why it would be 24 cubic inches. All right, so that's how example 2 works. Honestly, that's kind of a tricky example for the level we're at right now. Sometimes the book has some examples in it that I think are a little bit more complicated than we need to be right now. Okay, but the key is, the main thing that you need to understand is right back here. When you are multiplying and your bases are the same, like both of these are 3's, you can just add your exponents. 4 plus 4 is 8. All right, now the next rule that we need to learn is the rule of powers of a power. How do you find the power of a power? Write an equivalent expression for 5 squared to the 4th. Okay. Well, this means I literally have 5 squared times 5 squared times 5 squared times 5 squared. So I have 5 times 5. That's what 5 squared means. Times 5 times 5 times 5 times 5 times 5 times 5, which means I have a total of 8 5s. I could write this as 5 to the 8th and express it like that. That's equivalent to this expression right here. So look here and tell me, is there an easier way you could have gotten from here to having 5 to the 8th? And you might be spotting, well, hey, I could multiply 2 times 4. And that's exactly what you want to do. You want to take 5 to the power of 2 times 4, which is 5 to the 8th. So when you have a power, exponent of 2 raised to another power, you can just multiply those exponents together. All right, so when dividing, you can do just exactly the opposite of that. You can go ahead and subtract the exponents. See, this literally means 6 times 6 times 6 times 6 times 6. That's 6 to the 5th. Divided by 6 times 6 times 6, which is what 6 to the 3rd means. These right here, if you were to treat this like you were simplifying a fraction, these are all going to cancel right out, leaving you just a 1 in the denominator. So all that's really left is 6 times 6, or 6 squared. You could even go a step further and say that equals 36. What's my shortcut to get from here to here? Well, just subtract your exponents. 6 to the power of 5 minus 3, which will equal 6 squared. Okay? So when multiplying and your bases are the same, you add the exponents. When dividing, you subtract the exponents. So let's try a few examples here. I think this is going to help you a lot here. Here I have in part A, we're just solving each of these. 7 to the 3rd, it's being squared. Power to a power, we multiply those exponents. So it's 7 to the power of 2 times 2, which is 7 to the 6th. Same thing here, power to a power. So it's 4 to the power of 5 times 3, or 4 to the 15th. I know I'm moving kind of fast here. Multiplying, what was the rule for multiplying? Our bases are not the same this time. This one's a little bit different. We have 9 to the 4th times 8 to the 4th, but they are both raised to the same power. There's another rule that I didn't mention to you. When this happens, you can actually take 9 times 8 and then raise that to the 4th, which would be 72 to the 4th. And that would be it for that one. And then this last one, 8 to the 9th divided by 8 to the 3rd. This time our bases are the same. It's an 8 in both cases. So you can just subtract the exponents. It'll be 8 to the power of 9 minus 3, which is 8 to the 6th. So one new thing that I showed you right here on this page is what to do when your bases are not the same. And you can actually, since they're both raised to the 4th power, just take 9 times 8. And then that value will be raised to that 4th power. Okay? I think we're pretty good at this point. I'm running out of time, so I don't have time to show you much more. Very quickly, 7 to the 12th times 7 to the 4th. Any idea how to write that? An equivalent expression would be 7 to the 16th. Just add those exponents together. Power to a power, we multiply the exponents. So this would be 8 to the power of 2 times 4, 8 to the 8th. Okay? That's about all the time I have for you. So your assignment, please do 9 through 23 all, pages 43 to 44. Good luck, everybody. I hope to see you tomorrow.